If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hello and welcome to a live stream. My name is James and I'm the Bald Engineer. If you can hear me okay in chat, let me know by telling me one of your favorite components, or just a component. Doesn't have to be your favorite. But if you've been around for a while, you know I always like to ask that at the beginning. How is everybody doing? Let me drink some tea. Of course, I just realized if I had my microphone backwards, then you heard nothing until I gulped the tea. Okay, I'm learning. See, I'm learning. Let's see, I want to say hello to a few people in chat. Saw a couple of new faces. Welcome to the new people. If you don't know, I'm the Bald Engineer. I host a YouTube channel called AddOhms. I also host a YouTube show called Workbench Wednesdays on the Element 14 Presents network, as well as I do a bunch of writing for baldengineer.com and Hackster.io. We are going to be doing a KiCad project today. I've been streaming this one the last couple streams, and so we're right to the point where it's time to start laying out traces. Hello, Albert, Kira, Babin, you're around. That's good to see you. Cliff, David Boyd, man, I hope I said it right this time. Tom, good to see you. Armand, Lol1. All right. Crafty Nerd 81. Oh, hey, how you doing? Okay. I totally agree that component manufacturers should use redline in data sheets. Now, I do know some of you haven't been following the last couple of streams, but if this is your first time here, fantastic. I'm glad you're here. Couple of things to know. One is we do have a Discord server, so if you want to keep the conversation going, feel free to head over and check that out. And then for those who have been to streams before, you might notice that this is a newer looking background. So over the last couple of weeks, I have actually moved. Still in the process of unpacking. In fact, I'm super excited for the holiday weekend. My brother is here and he's helping me do a whole bunch of housework while I talk to you guys and play with KiCad. So not quite sure how I convinced him of that, but I think it's pretty cool. Well, I mean, it's very cool of him, but it's pretty cool for me. So anyway, this is going to be my new office. This is not going to be the new lab. Still having a couple of things I have to do before I get that set up. And I haven't found my sound absorbers yet. So apologies for the echo. Before I get going, before I get going, I just wanted to point out, I am wearing my Never Trust the Auto Router t-shirt. Chris Gamble sells these, or has sold them. I know there was 2 runs. I bought one from each. I don't know if they're still available, but one of my favorite shirts. Where's the 3D printer? Funny story. I was realizing as I was unpacking, I hadn't found the box that said 3D printer on it. And then yesterday or the day before, I found a box that says Prusa Scale. So when the movers packed up my Prusa, they thought it was a scale, which of course we think it's funny because we know it's a 3D printer, but you know, if you actually look at it, it really looks like a scale. So what are we going to do today? Okay, we are going to be, let me move this out of the way and then I can switch to my screen. Let's kind of put it right here. Yeah, okay, so let's switch over my screen and here, yeah, you can see that, perfect. So this is the circuit we've been working on. This is a shield or a wing for Adafruit's feather boards. So let me show you a couple of things on that. So first of all, the project files, the ones that I'm using right now, are available on GitHub. The only thing to make sure is that you go into the branch that is the board 1 development, version 1 development, because that's the one that I'm working through. So what I decided to do is I created a branch for the version of the board, and then once I send this to OshPark, I will I'll push that. I'll do a pull request into the main branch for the project. So that's there. For those who don't know what I mean by feather, so Adafruit has a series of small boards that have all kinds of different microprocessors and all kinds of different radios on them. And then they have, instead of shields, they have what they call wings that attach to the top. And so we're creating a wing that has temperature, humidity, light, and sound, because those are 4 things that I want to characterize throughout my new house and workshop to see how things, well, basically see what it looks like over time. And so that was my idea here, is I wanted to build a shield or wing that does that. The reason I picked feather is a couple reasons. One is it's more adaptable since there's all kinds of different types of boards out there. And two, I already have a bunch of them. So it sort of eliminates the extra cost of designing in a microcontroller. So we're going to be doing that. I want to make sure we have that open. And then that way, when somebody says again, what's going on. So just to do real quick through the schematic, basically, we have a real-time clock. And I picked the DS32, let's turn off the grid. The DS3231 because that's one of my favorites, and I have a bunch of them. The APDS996 is going to be our light and proximity sensor. TechZ, our friend from Germany on the last stream was pointing out that the original microphone I used was end of life. So I've switched to a newer or a actively available microphone. So for a sound sensor, we're using what's called a PDM mic. It's a pulse density modulated microphone, meaning it doesn't output an analog waveform. You send in a clock, and what comes out is sort of like pulse width modulation with audio information on it. And so, so I did switch that out since the last time we streamed. We decided to do our own power on board. Also, I'm using this 3.3 volt regulator because it has an enable pin, which allows us to, from the microcontroller or the feather board, turn the sensors on the shield on and off. So we got to thinking about it. If the microprocessor goes to sleep, we might as well turn the sensors off so that they're not wasting battery power. The SHT30 is a temperature and humidity sensor. So we got one of those. We also have a micro SD slot. And then, of course, LEDs. We've also included a circuit so that we can actually measure the battery voltage, so that we can keep an eye on that. Since we had the extra pins, I decided to add a voltage divider so we can tell when the board is plugged into USB. So on the feather footprint, let me show you that. There's actually a VUSB pin which is connected to the V bus of the USB connector. So by using that voltage divider, we can just quickly check and see, are we plugged into a wall or not? And I don't know, maybe it's useful, maybe it's not. I decided to go ahead and just use up all the pins because since this is meant to be sort of a data logger, we can actually delete that too. Well, because that's already done. I figured it'd be good to know whether we're running truly on battery or if we're running off of USB. Okay, so that's sort of an overview of everything we've got going on there. And feel free, if you have questions about any of the parts we're using or why we're using them, please let me know. Now, let's go over to the printed circuit board. And you'll see I've been adding some notes for myself. There's a couple of places where we've added jumpers. And on those jumpers, I need to go back and make sure I clearly label what they do. Like I've got the name of the jumper on the silk screen, but I should identify what is the actual functions so that I don't have to look at a schematic every time I want to use it. So, that's not doing what I want. So this is the feather wing layout, and I have placed, let me turn the rat's nest off so it's a little bit easier. I have placed the parts as such. I've put all three of the main sensors on the edge of the board. This is also the edge that the Wi-Fi, or I say Wi-Fi, that the RF antenna comes out for all of the feathers that have RF radios. And so my thought was, if we 3D print a case, then we'll probably leave this edge exposed so that the sensors get exposed to the environment and the Wi-Fi radio or the antenna is also exposed. Now, one of the things I did off stream is I laid all of these out and then I put the components that go with each of the parts with them. So all the decoupling caps and then any of the resistors as well. Over here is the real-time clock, and then down here is the circuit so that we can actually test the battery voltage. Up here is our voltage regulator, which is connected really close to where power comes in. And then over here is in the red is the micro SD slot. Now underneath it, on the bottom side of the board, I have a pad layout for a coin cell battery. Now originally I wanted to use a 12 millimeter coin cell, but it turns out that that was just a little too big for this board. So I decided to go with a 10 millimeter, which looks like is relatively easy to get a hold of one of those batteries, and then the clips are available as well. Just as a reminder, the coin cell is only here to power the RTC. It is not meant to power the feather or the sensors, it's just to keep time on the RTC. Yeah. Now, this layout did create a little bit, there's a couple of things I don't like, but I think that because of engineering constraints, it's what we have to go with. So everything on here, so the RTC and the 3 sensors are using I2C. So I wanted them to be near the I2C lines since it's a shared bus. The trade-off to that was the micro SD card slot. It uses SPI, or the serial peripheral interface. And so it's over here, its pads are over here, and it has to connect to the pins that are down here. And so that, less than ideal, but I decided that's just what we're gonna have to go with, because I would rather, well, because 2 reasons. I wanted the sensors to be on this side of the board, so that made sense. And we just decided we had to make that trade-off. I also, and nobody probably cares about this, but when I did the schematic, once I laid out the components where I wanted them, I actually rearranged all of these signals so that the signal on the pin is close to the components in question. And I said that when we first laid out the schematic, that I was just randomly assigning pins to have different names. So I hope you live or live RRD3 layout. Sorry, I don't know what RRD3 means. So we got all that going on. Now, what we haven't done is we haven't laid out any, or haven't done any of the traces yet. The rat's nest, it kind of looks messy, but for the most part, I've tried to orient all the parts near wherever they need to be. But what I kind of wish is, I wish KiCad had a way to, I wish I could tell it to turn off things like the 3.3 volt and the ground nets, because I'm going to do a 4-layer board and they're going to have their own plane. So I don't really care to see their lines anywhere, but I don't seem to have a good way to turn those off. So, oh well. The way I'm thinking about doing this is we'll do top layer and bottom layer for signals, and then in the middle I'll do power and ground. Power being the 3.3 volt rail, and then ground being ground. We'll see how we go. Maybe we'll end up turning the bottom layer mostly into a ground plane as well, but I'm not sure how many signals we're going to have to route. Yeah, DDR3. Well, I have never done DDR3 on KiCad, and also I would probably not do DDR3 in a new design anyway, because in general, DDR3 chips are more expensive than DDR4 because the market quickly adopted DDR4. Oh, cool. Hey, Michael. Yeah. I hope this will be useful. Just to back up, because I've had people offline ask me this. I looked at the alternatives I looked at is Adafruit has a feather board that has a bunch of sensors and a microcontroller on it, and that runs like $30 to $35, which is a pretty good price for what's on the board. But to have, if I want like 5 or 6 of these in my house, that starts to add up pretty quick. And plus, like I said, in my case, I already have feather boards. I already have the expensive electronics. I just needed the sensors. The other thing I noticed is every sensor board included both an SHT temperature humidity sensor, and then they also included a BMP pressure sensor, which itself has humidity and temperature. So there was kind of an overlap there. And I just decided in this build, I didn't care about barometric or atmospheric pressure because I'm not really trying to measure altitude changes with this board. I want to know, how does the temperature of the room change over time? How much light does it receive, or how much light will my flower beds get during the day? I wanted to know those things. Also, every sensor board comes with an accelerometer and it comes with an IMU, inertial measurement unit. So accelerometer, gyrometer. gyrometer. Why can't I say the word right? And a magnetometer. And so I don't need those either. So I thought it'd be kind of cool. Just have the 4 sensors: temperature, humidity, light, and sound. I do have the sound on there for a very specific reason, but I'm going to hold off on that reason because that's going to come up in an Element 14 video. Okay, now, before we get to the traces, I discovered something, and I thought this was like a well-known feature in KiCad. I don't know when this got added, and I don't know why more people didn't know about this, but I tweeted this the other day, and it's been one of my most popular tweets in a very long time. So since other people didn't know about this, I want to talk about it and show it real quick. So let's turn off the rat's nest. Now, one of the frustrating things is when you include packages, and especially if somebody else has created, say, your footprints, the size of the text will always vary. Like some will be kind of bigger and smaller than each other. And so I've left on the feather header, notice how, like, if we look at, this is a really good example where S-Clock and MOSI and MISO, or some people say MISO, they're different text sizes. And I think the reason that this particular author did that is because they're trying to make the text as big as possible and then to make things fit. But I don't like when text is different sizes like that. I'd rather make everything on here the same size. Same thing with all of the individual components, is not all of these components had the same size. But I found a trick, or a feature, or a trick, I don't know what you want to call it, that it's really easy to change these all to be the same size. And I can't believe I didn't know this. So I'm going to go, so the way we do that is under the, now this is in 5.1, what version do I have? Oop. Like I said, I don't know when this got added, but I feel like this is kind of new, or relatively new. So 5.1.6. If I go into edit, there is a menu for edit text and graphic properties. Okay, so in here, we can say what is the scope that we want to change. So before, I did footprint references and values. This time, I'm going to do PCB text. And then you can also filter if things are only on specific layers. So like if you want to change the silkscreen layer, but not say the courtyard or the fab layer, which doesn't normally come out on any of the Gerber files. But there's that. And then down here, so the scope, what do you want to change? How do you want to filter it? And then down here are the values that we want. Now, I basically looked at the text and I already know that I want my width and my height to be 0.5 millimeter. And I want the thickness to be 0.1 millimeter. So I'm going to move this over to the side. So remember, let's look at this text down here, specifically these three, the SPI signals, and click OK. And ta-da! All of my labels now are the same size. I think that's wonderful. And I really wish I had my Monty Python thing, because I would say there is a need for much rejoicing. Yay. So yeah, so I did that on the parts. That worked really well. And then now I've done it on these. I mean, that's one of these things that I usually wait until the very end of the board and I normalize all the sizes and everything as I'm moving stuff around. But my gosh, doesn't just making everything smaller, because you know this is a small board, but at least making them all the same size, it just makes the board look so much cleaner already. Okay, so now I can delete that to do, and then these got moved, or these got changed. So let me just move these so I don't forget about them. That's really just notes for me. So am I being picky that I want the R1 silkscreen to be the same orientation as C2 and CR? So some of these I oriented on purpose, and some I did not. That one I did not. So let's actually fix this one. Now again, normally I don't actually go and muck around with the silk screens until I'm closer to being done. But what I ended up doing is I took each of these circuit sections and I actually did something like this, where I just said, okay, I'm going to move this over. I'm going to move all the parts into one area. And then I sort of clumped and laid them out together. And then I put them back. And so I did, in this case, decide, let's go ahead and kind of mess with the silk screens, because I want to try to keep things as consistent as possible, knowing that I'm probably going to have to go back and redo things. So there's a couple of things I don't like about this current layout. So R1 is in the wrong place, C2 and CR are completely off grid in axis from each other. In fact, this component, these three components have different probably Y values. So I'm going to right click and I'm going to go to align distribute and align to center. So now all three are aligned, and then I'm going to go align and distribute horizontally so that they're all spaced out nice and clean. And visually, it looks like we're roughly in the center of the chip, or at least close enough that I'm okay with it. So now I'm going to click just on the designator, hit M for move, and then I'm going to move it until I see that the x-axis is directly in line with the center point, and I'm going to do that for this one as well. And then we'll check this one. Looks like it's off a little bit. So now it's directly, looks like it's directly there. So now I'm going to highlight just those three designators, right click, and then I'm going to say align to top. And I don't think I like that. Let's try align to bottom and see if they shifted. Still doesn't look quite the same, but now I'm just using the, okay, let's do this. We'll click each one, hit M. Now I'm going to use the keyboard and move those to be closer to their parts. And then, oh, come on, really? That was terrible. That doesn't look, oh, that's weird. Hold on. So if let's try something. Let's get this to be here. And then let's distribute these. Yeah, okay, these parts must have different width. All right, and then, now one thing I've noticed is the align top and bottom and left and right are not always the orientation I expect. Yeah. The microphone, are you going to register the waveform or something else? I'm just going to measure the sound level for this board. Now, I've never used a PDM microphone before, and so I'll probably use this board as a chance to see what else we can do with a PDM. PDMs are popular in laptops and cell phones, so you can get full audio range out of them, but all I'm looking for is we'll do like, we'll just check to see what the sound level is every once in a while, just to get a sound level. But it is kind of overkill for what we're doing on this board. So the reason I'm using it is because I want to get experience with that type. Freeman, how much more would you pay for an open source microcontroller, blah, 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 over a proprietary one? Open source is not usually a decision criteria for me. I pick whatever the appropriate tools are for a job, whether it's the software tools or the pieces of hardware that go into it. I know that makes me a little bit different than most people, because I know most people are absolutely adamant that you do not ever give money to anything because everything should be free. I feel like you should just pick what is best, and not just because it's open source. One thing to remember is if all you do is use open source software or hardware, you're not actually contributing anything back to the community. If you're going to use it, contribute something back. It doesn't always have to be monetary either. So anyway, I don't want to get into that rant. Anyway, yeah, so to answer the question, how much extra would I pay for an open source microcontroller? I would pay $0 extra. If it's not cost competitive with the proprietary ones that are already available, then I'm probably not going to use it. But that is just me. Feel free in chat to discuss what you would do or pay. Although I just realized I probably biased the decision or the criteria a little bit by saying what I said, but oops. Okay. I don't want to spend a lot of time cleaning up the silk screens right now, but let's get a couple of these out of the way, just so that, let's see. I don't think there's going to be a good place for that to go. But I was just thinking, let's get the ones that we need, or let's make sure there's not too many that are overlapping at the moment. I want this footprint. And then I want value. I'm going to move this one over here. I mean, that's a little bit of overlap. I don't know why these two are. Let's try align bottom. Okay, that works. These all look pretty good. Anything up here, LED enable, jumper 5. We can actually hide this one. So E to edit that, make it undo the visible. And then let's move LED enable. Oh, you know what? I'm not thinking clearly. The green is on the backside, so that's going to be easy to read. D1 is inside there because that's the only place I could fit it. JP5. Oh, is this? That must be on the fab layer. So we'll just ignore that for now. I did notice J3 was off board, which is silly. Don't really need it, but let's go ahead and just put it here. Okay. The rest look okay. Like I said, I don't want to spend too much time moving those around because until we're done routing, the designators might move again. I just wanted to get them out in the clear and open so that we could see them. What is the name of the program to get hardware info on my taskbar? I forgot. It's no, not Task Manager. Oh, there it is. X meters. Game Tech, you may be get up early. Which side of Canada are you on? Are you on the left side or the right side? For some reason, I thought you were on the east side, but like I thought you were like from Montreal, or is that still early for you? Okay, so let's turn our rat's nest back on and let's look at a couple of things that we could easily route. So let's see. Something that's going to be critical are the SDA and the I2C signals. So let's go ahead and get that going. But first, we need to define. Where did it go? Where did it go? I want to define the DRC for the traces. I feel like every time I use KiCad, these move around. So I didn't define net classes. So we'll do assign specific values, 9 mils. Okay, how do did they get rid of the classes now so that I can just come in here and say predefined, I want 6 mils. Via, I'm not as worried about, but track less than what? Okay, what are the, okay, so I'm used to doing it by net class, which we may still come back and do that anyway. Clearance, let's do 8 mil. Track width, I'm gonna leave that at 0.25, but I want the clearance to at least be 8. Okay, is that, and then failed to update user configuration. Okay, that'll be fine. That'll come back. Okay, so that's how we get it to our smaller traces. And then let's go ahead and just add one for, let's do one more, and I want it to be 16 mil. Net classes, this one, enable this signal. Basically, I'm looking for the power signals. I'm going to end up using planes for most of the powers, but I figure why not do this now. Okay. Let's see, net class filter. That's not what I wanted. New net class. Let's see, assign to list it. Assign. That's what I should have done. Power. 8 mil, track 16 mil. All right, and then I want to assign to selected nets. Nope, net class, power, assign to selected nets, apply. that's not what I wanted to do. New net class, oh, assign. Okay, so I created, so our typical nets will be 8 mil, and our power nets will be 16, although I'm gonna use planes for that anyway. Oh, you are on the West Coast, man. I did not realize. All right, so, and this is a Dropbox issue that I have. It'll get updated eventually. Like if I save it now, I think it'll be fine. But for some reason, I get Dropbox errors every once in a while. So we're just gonna blame Windows, because when I use the Mac, that never happened. All right, so all I'm doing at this, okay, let's do this. So I've saved. At this point, I just wanna do a little bit of a rough layout to see how things are gonna look. So let's, in fact, can I do a save copy? And then let's just do before rough layout. Okay, that way we can come back if we need to. It seems a lot bigger than I was expecting. Oh no, okay, it's the keep out. All right, alrighty. So we're already off and trying to get over here. I don't like that at all. I think that looks pretty bad, but we'll kind of go with it for the moment. And then SDA is gonna have to somehow, can it come through here? We can maybe do that for SDA. Where's this clock on this one? Ooh, that's gonna be tough. And then the microphone doesn't have I²C. So then we've got to get over to the RTC, and let's just for the moment, I'm gonna try, ooh, I'm actually thinking we're going to end up, oh, come on, stop trying to help. I'm gonna come this way, and then come up this way, up, around, and into here, because then I want the clock to come around like so. And then that's going to be an easy one up here. So how are we going to get clock around? So I guess we could come up around this way. Ooh, nope, that's going to be a problem. Shucks. Well, that didn't take long to run into a problem. Okay. So let's think. If we had instead, I forgot. There's a hotkey to rip up the entire trace. So instead, if I had brought clock around this way, what we could have done is take clock, yeah, we'll hit it there, but then come, no. We can come here, and then that gives SDA a chance. What I would like SDA to do is maybe come up around this way, something like that. And then that way I can bring clock back this way, and we can get it into, I hate going between surface mount parts. We can get them into there. And then where's clock on this chip? Of course, it's way the heck down there, of course. So ground's gonna be easy. This we could via, don't like that at all. Do we have enough space? What happened? Do we have enough space to come in through here? No. All right. We could just do one of these. Not super excited about that. The problem's going to be, how do we get this ground? That ground's going to have to get a via. So we'll have to think about, maybe we have to shove everything over a little bit. I don't know what pin this is. Ooh. Well, we can bring this out to a via and get around to there. That's going to go to a via. What's this? This one's going to have to go to a via. So I think what we're going to end up doing is we're going to have to move these to be, I'm going to hit G and see, nope. Maybe move these over a little bit, something like this. And then that way we might have enough room for vias. And then I guess we could always move these components over a little bit as well. So we should be able to make it, we can make it happen. I'm not gonna worry about it at the moment. As I said, at the moment, I'm just trying to get a rough idea where's our problems gonna be. So now let's see how we're gonna get the, hey, Thermite, good morning to you as well. RJ, great to see you. Game Tech, I didn't call you out by name. I did make a mention about Canada, but I will say, hey, Game Tech, how you doing, man? You working on any new Raspberry Pi videos? So, people don't know, Game Tech does do stuff on both Twitch and YouTube. Had a good Raspberry Pi video recently, and I'm totally blanking on what it was. What was the most recent one you did? Man, now I feel really bad that I don't remember. As soon as you tell me, I'm going to remember watching it. I just can't remember what it was. Let's kill this, kill that, kill that. Let's go back to wire. Come through here, up here. And then this. Okay, so that's going to have a little bit of trouble getting back into there. I wonder if I have my margin set too high. I feel like these are... you know, the other thing we could do is if I flip these resistors to go vertical and then make this decoupling capacitor be horizontal, it won't look as pretty, but I think I can get signals to go through here a lot better. And then I might be able to shift the RTC over a little bit so that we get better access to PDM and clock. Also, I just realized we're gonna have to change this pin out because I'm gonna have to try to get the PDM signals to come around to these pins, but then I've got the 3231 pins over here, which are going to cross back over, right? So let me just show you okay, well, that's an easy fix. So like this signal, this PDM clock signal is here. That's what this one is. See? And then I was going to say, oh, then let's take this signal and then come all the way like down here or something, which is really silly. What we ought to do is move the PDM signals over so that everything is lined up better. So let's do that. Okay, so I'm going to save that. We're going to go back to the schematic. And what I want to do is I want to swap these around. So let's move this over here, move this over here, move this over here, move this one up, move this one up, and then move this one over, move this one over, move this one over, and save that. And then back in the PCB, I'll say basically push the changes, update. So now we can do PDM data, PDM clock, 32, and reset. Cool. So now we can do reset. Let's just see what's going to happen if we try to come around this way. And then interrupt is getting stuck. Man, what is my... I keep forgetting where that's at. I want to change the... well, double check this. Oh, shove. Was that because I wasn't in shove mode? It was. That's what was going on. Okay. So in the so KiCad doesn't have an auto router, which I'm totally cool with, but it does have an interactive router, and one of the idea is, or one of the modes is shove. And so what it'll do is it'll actually move traces around so that you can get things to fit within the constraints that we've said. And so like I've said, I want an 8 mil spacing between my traces. And so yeah, I thought it was on shove, but it was on walk around, which meant it wasn't doing what I wanted. Optimizer effort. Oh, let's go high. Why not? Why would, that's silly. The no micro SD card boot. It must have been the no micro SD card boot, because I was thinking it was something to do with the SD card. Like I'm picturing I can picture the thumbnail. Oh, cool! You're gonna stream, or continue streaming, I should say, because I know you tried a couple times, or at least once. I don't know if it was more than once. All right, so 32 kilohertz, and then that's gonna go here. Not gonna worry about that one. That's gonna go here. Reset. Okay, cool. Now let's get PD clock so he's going to come up here and then data. See how now it's like, okay, so I'm gonna try to help it out and say, okay, look, come out right about here and then shove around these components. And can we get 2 traces in here? I don't think we can. No, we can't. So let's come up around here and check that out. Now, this is kind of silly. Okay, so I don't like this because this is supposed to be the decoupling capacitor for my sensor. And so what we need to do is let's take this trace and we're going to wrap it around this way. Come up to about here, do that, and then, ooh, that looks too close. Wonder why it's not, oh, this, you know what? I don't think KiCad knows that that's a pad. That's probably not defined well. It's probably a problem with the package. So we're gonna have to help it out. Let's come down to about here. Yeah. Okay. And then that way that gets through. Ground will go to a via. These are going to go vias. I should be able to get vias in here. Okay. So that's looking, this is looking promising. What I might end up doing is I might revert back to the version without the traces and reroute the SDAs because I didn't have shove turned on. So we might have been able to get a better layout, but at least this so far, I'm feeling pretty good about where we're going with this. Let's see what signals are up here. So we'll be able to get a via for power. So this interrupt signal, I think these two just actually short together. This signal needs to go where? Way the heck down there. So I don't know how we're going to do that. Can I get through? I can get through to about here. The reason I don't want to go, well, okay, wait. Nope, see, it's trying to shove me. That's really close to that hole though. Yeah, so I'm thinking this footprint, this must not be defined as, okay, there it is. This extra pad must not be defined. Let's see if we can do edit footprint. I see what's going on. So let's see if we can get, so is it a polygon? It's a polygon, that's why. So interactive router is not seeing this polygon as a problem. So we're just gonna have to be careful with it. That's all. Let's kill this, kill that, and then bring this up to about here. Okay, that looks a little bit cleaner. All right, cool. So then what's left on here? So this, what is this pad? Ooh, that's nasty. What is that? Is that the power? Why does this go to, oh, this is a pull-up resistor. Okay. So we should be able to via that to the bottom, bring it around back up to the top. So not too worried about that. And then where, oh, I see. So this one connects to here. Ooh. So what we really need to do then is kind of do something like this. And then, crap. How do you do a via? Yeah, it was V. Why didn't, that's weird. I wonder why that didn't work. So route, grab this guy, come to, maybe it won't place it there. Let me try this. Yeah, okay, so I gotta get to a smaller via. All right, so I'll have to go check, see what the smallest via we can do on OshPark is. Because we're gonna have to get that one out, and then, so what we'll do is, we'll put a via for this signal, we'll put a via here, and then we'll bring it around to here, unvia it, and get it into there. Or, wait a minute. Wait. Oh, actually, perfect. So we just gotta get it to the backside anyway. No, oh, I totally read that wrong. So this pad is on the copper layer, and then this pad is on the bottom layer. But we're still gonna need two vias to do that. That's a bummer. Yeah, that's gonna be a small via, yeah. Yeah, I think we're gonna have to redo these decoupling caps. I think they're gonna have to go horizontal instead of my vertical orientation. This is a pull-up resistor and an enable pad, so I'm not too worried about where that goes or how that looks. But I think we need to turn the capacitors so we can get more space. I mean, really, if you think about it, all of this is wasted, so we can definitely get a better optimization. So I think that's what we'll end up doing. Like I said, we'll revert, make sure that the pinout is correct, and then I'm going to turn these capacitors. I was trying to go for a smaller loop area, but I think we need to do that. Okay, so let's see, then that would have just left, so those two, I'm not gonna worry about them right now. Grounds are all here. That's ground and power. I'd really like to find another place for this to go. I don't think we have a choice though. I think that's just gonna be kind of a nasty route. Nasty route no matter what. Okay, let's see how the battery measuring area is going to go. Let's see, VBAT, we'll do that. That didn't look like it got bigger. But yeah, this should have been a fat trace. So why didn't the net class take care of that? Okay, bat measure, that's an easy one. This looks like an easy one. That's an easy one. Actually, VBAT, I should look at if we can do that as a flood. Okay, and then this one has to somehow get back up there. Okay, so what I think we'll try is, what if we come around? Oh my, I just realized, no wait, that's not what I think it is. Okay, never mind. So this, we could probably come up around here. That's an enable signal. It doesn't require a whole lot of effort. or care, I should say. Everything takes effort. So that's it. Where else does VBAT have to go? Okay, so that's not good, because we're gonna have to get VBAT. We got to get VBAT around to here. So let's rip this up. Actually, man, I cannot remember. There's a hotkey that rips up. That deletes the whole track. Delete full track is delete. Well, that's not working. That's what I'm pressing. I'm hitting delete. Or am I? Let's try it on this one, then I'll undo it. So if we select that and I hit delete, yeah, delete is not. What if I do backspace? Okay. Lie. That's a lie. What a lie. 0402 or 0603, they're actually 0805s. And the reason I went 0805 is because I have a boatload of them. We could have, and it looked like 0805s will work, and they're just a lot easier for me to deal with, so I decided to stick with them. That said, I could definitely see doing a version of this with an 0603 and making some other optimizations later on. But my primary concern was, or my primary thought was, I have plenty of 805s in my stock, so I want to kind of use those up. No, I want the via there, so that we can go, page down, so we can go there. Oh, man, life just got tons easier. Since that's on the back side anyway, let's just come out here and do a via like right away. And then this can trace out to here. And then let's go back to the page up to the front copper. Now I can do my meandering. This signal can go, basically, we're just going to come back around. I don't know why you're wanting to shove it. We can do one of these. And then, what are you doing? Say what? Okay, good enough. We're gonna redo this layout anyway. Okay, so what challenge does that present? We need to get this signal to the holes over here. So if we via that, that'll look really good. Okay. Now, where does this one go? This stays on the back side and it comes over here somewhere. All right. I am just going to avoid the IC because I want to make sure I get ground planes and stuff under that. So that's going to look pretty good. The interactive router loves shoving a bit too much. Yeah, you got to really, I call it hinting. You got to really hint to it what you want to do, which is frustrating, but I'm not going to get too upset about it. Okay, so I didn't want this to be, I wanted this to be this track width or this one. So why did, oh, come on. I'm doing something wrong with the tracks because this should all be working with like no problem. And then like this track is huge. It's freaking huge. It's bigly. But it's a beautiful track. Tremendous. Beautiful. All right. I don't know why I care because, like I said, we're gonna rip all this up again anyway and start over. But I really like to do this where you just do one full layout and then rip it up, make some optimizations and do it again, because then we can see, are we going to run into any major issues? Okay, so like what do we got going on here? So this comes up, wrong side, page up. This is going to come up like this, and that connects into here, which again, I think this should actually be a flood, but I'll worry about that in a minute. 3.3 volts are going to connect through the middle plane that I haven't created yet. Regulator enable, is that going to make it up through here? Looks like that's going to work. VBAT. That's going to connect all up. And then what is 3-volt regulator enable? That loop around here. Actually, no. What we're going to do on that one is we're going to try, can we get around like so? Yeah, we're going to do that instead, because that way I can get a via from here and a via there for ground and for VCC. VUSB, that's not going to be a critical signal, because that's just, we're just doing, do something like this. Okay. So that'll end up working out okay. That's 3.3 volt. That's going to go to a ground plane. So BAT plus, that is going to just, that's going to be pretty easy. RTC BAT, where does that connect to? Oh, okay. So we're going to have to get a signal from here all the way over to the RTC, which actually doesn't look like it's going to be a big deal. So let's page down and get to the copper layer. I'm basically going to say it's going to end up being something like this. Okay, so that'll work. And then we'll do this via to my ground plane. And then over here, then we'll have to do this, and oops, this is going to be 16 mil. Yeah, something with the recent version of KiCad is doing, it's not handling traces the way I'm used to it, but we'll worry about that later. Okay, so now I need, let's go back to copper layer, and then let's go back to an 8 mil. Oh, no, this is going to be a 16 mil. Oops. Let's go 16 mil. And then that's going to come into here. 3.3 volt. I think we can go ahead and safely go like this for purposes of now. And then this to here. Actually, I don't need to connect to 3.3, so we're going to via those. Okay. And then a bunch of ground signals, not too worried about that. LED looks like it's going to be pretty straightforward. Just come up to here, come up to there, and then ground. Okay. Okay. I think, oh, where's this one got to get to? So that might be able to come, God. It's like, it's okay. You can, you don't have to hug everything, man. It's fine. Yeah, we're gonna have to do like something crazy like this. But I think that'll work. And then ground, that's gotta go to a via. That'll work. Okay. All right. Net class not working. Yeah, I don't know what's going on. Yeah, I'm not gonna worry about it right now. We might look closer into it to try to understand. Click a track, press I for the whole track. Is that the magic key? That is. Thank you so much. I cannot remember what the magic key was for that. Okay. So the only other thing that's okay, if we just use the pins as a guide, so ground Oh, we haven't figured out how to route. Yeah, that's going to be important. We got to figure out how we're going to route the SD. Crap. Oh, crap. Oh, that's not going to be easy. So how are we going to get... I should have done these first. Yeah, I just don't see how we're going to get these around. Okay. Okay, so let's see. What's my notes so far? So to do round two to do, we're going to sensor decoupling, change to vertical or change to horizontal. Make sure PDM and RTC signals are swapped. I think all I got to do is when I reload the old PCB file, I just need to push the changes from the schematic. And then let's see, what else did we run into? Oh, make sure enable put or shove routing, and then route SPI signals before power sections. Okay, checks net classes. Okay, I think that'll be good. I think that'll get us where we need to go. Okay, and then what? Oh, I know. Oh, I'm so silly sometimes. I have that layer turned off. Oh, come on. Because I had the layer turned off, it didn't place it? Are you kidding me? Is that literally what just happened? Okay, so that worked. Now I'm going to turn the front fab layer off and try this a second time and say okay. And okay, so it's because I hit escape before I actually clicked, so it didn't save it because it was not being shown. That's frustrating. That is really frustrating. Okay, round two to do. Route SPI, okay. So check net classes. And then rotate sensor decouplers, horizontal, route SPI signals before power section. Double check PDM and 31 signals push changes. It's too bad with the SD signals, simply jump them on the back. Well, I think what we're gonna do on those is actually let's look at that. No, oh, whatever. Okay, all that because I'm gonna end up copying and pasting that into a text document anyway. So I think what we want to do on the SD signals is we're going, like you said, MacGyver, we're going to basically we'll via them to the bottom layer and then bring them around here. And then that will bring them up. Yeah, we'll bring them through this whole section because this isn't a power critical section. It's actually the all we're doing there is it's a circuit so that we can check the battery voltage. So I don't care about the ground plane quite as much there. So yeah, so we'll via those down, and then we'll bring them around, and then once we get them routed down here, then these two signals that have to come up this way, what we might be able to do is get them to come up on the copper side. Because like if I look at like one thing we could do, just as an example of what we can change right now, and this actually just all this does is help me see that this is going to work. Can we get this to fit through here, and then this to fit around here, and then do something like that? Yeah, see if we can do that. Is it this one? It's that one. And then what about this one? Okay, I'm not gonna worry about that. So now so we'll be able to bring the SD signals through here, and then that gives us some room to negotiate with those. But I think if we route these three first, then we'll get a much better view. And then one thing I'm trying to avoid, and this is just, I mean, if you have to do it, you have to do it. One thing I try to avoid is doing the like multiple vias. Like, okay, we could do, like I could come and say, okay, via this right here, and then run this to here, and via it, and then bring it across, and then via that, and then go into there. We can do that. I'm okay with that. But I'd like to have a layout, especially on like these SPI signals, which are relatively fast. I'd like that to be a little bit cleaner. The plus side to that is it does give us some really obvious test points. So, okay. So I think that's what we'll end up doing is we will, but like I said, I think if we redo those. So let's do this. I need to switch to this for a second. That was weird. I don't... Huh. Yep, that's why I wanted to double check. Okay, let's come back to this. Do you use an auto router? Well, as the shirt says, never trust the auto router. No, I don't use auto routers. I am okay with auto routing or interactive routing. So like if I'm doing a bunch of differential pairs, or say something like a group bus, like a DDR bus, I will make use of what I would call interactive routing features where it tries to help as you go. But I have never seen the value in taking a board and just hit auto route and then dealing with whatever crap it puts out. The reason I like to do this is because it allows me to cleanly place our components so that I get good signal integrity. And then also when I go to test the board, I already in my mind have an idea of where some of the traces are. It also, just like I said, gives me an opportunity to think about, okay, I didn't put test points in the schematic, but is there some place I could add a via that I could go and then test to use as a test point? So I have lots of reasons I don't like to use an auto router. But that said, I will use auto router like features. Like for example, KiCad has the interactive router where it'll actually push and shove signals around. I'm okay with that. I don't need to be that micromanaged with my traces. But I hate like Eagle's auto router where you tell it, oh, put all the top side traces this way and all the bottom side traces this way, and then it just comes up with a total mess. Now, that said, there are a couple of boards I've done where I have let the auto router go to town on it because it was like switches and LEDs and I just didn't care. It was just a whole bunch of stuff I did not care about. But in general, no, don't like them. Don't like them. They make a mess. They don't give me a chance to think about what's going on in the circuit. How's the circuit going to get used? The mechanical constraints, all those things. I mean, the thing is we've only spent about 45 minutes doing this quick routing. And that's after I spent about 2 hours organizing the parts. And so if I look at the time difference between organizing the parts and routing, where I spent most of my time was organizing. So it's, to me, it's, yeah, it does save time, but it doesn't, it's not saving all the time, if that makes sense. What am I doing? I need to go to GitHub. But it's going to want to, oh well, I can delete this later. Notes for round 2. And then let's go to, that's not what I want it to load. Projects, GitHub, let's edit this in Sublime. And then I want to rename this one, copy that, and let's just add this.txt. No reason to put that into the repository. Placing the components is the hard part, not routing. Yeah, actually, it's funny because, so when I learned how to use, so I started using KiCad full-time 5 or 6 years ago. It was at the first super conference, and I went through a workshop with Tom Anderson, and I think Anul was also teaching, but I'm not sure if I actually did a different workshop with him later on. But I was in this workshop and this guy said, yeah, I haven't used a PCB program in 20 years. And the thing is they haven't changed. It still is, you have to lay out the parts and then lay out the traces. And even with an auto router, you still have to do a little bit, right? He's like, why aren't they to the point where you just draw the schematic and it figures out where all the parts go? And, I think there's some iteration and machine learning type things that can be done to actually lay out certain pieces of a board. But at the end of the day, most of the time in laying out a PCB is figuring out where to put parts. And to put them in a logical place, you have to take into account the end application, how's the board going to be used, the mechanical constraints of where it's going to be used, like where there are holes is what the enclosure is going to look like. And then the third is electrically, where does it make sense for signals to actually be? For example, when we were looking at the signals on the pins, and I said, oh, you know what, PDM clock and data, by swapping those and the 3231 signals, we get much cleaner routes. Just to point out, if I had just, hit auto route, let's see how that goes, it would have just created a mess and it wouldn't be as clean. So anyway, yeah, I agree with everything you guys are saying, right? Auto routing is useless without good placement. You can't auto place parts. And so I guess maybe if I get off my soapbox a little bit and say, I'm not 100% opposed to auto routers, but I do think a lot of people misuse them. I think they just throw parts on the board and then say auto route. And if it completes, then they say, okay, I'm done. By the way, when I was the Eagle user, I did often hit auto route just to see what it would do. And I used that as a gauge to say, okay, is this board routable? Because if the auto router can route it, then I most likely can do it. That's not to say if the auto router fails, it's not possible, but it just gave me a quick confidence that, okay, there's enough room to do whatever I need to do. It's just a matter of the puzzle at that point. So, okay. Blah, 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 blah. Lots of talk. Okay. So we saved our notes. So now what I'm going to do is revert to last backup do what I want? Okay, to load recovery or backup file. I'm just going to see how far that goes back. Okay, so this looks like everything. This even has PDM clock and data in the right place. So I think this is okay. This will work. So now let's do I guess we don't have to do a save. So first thing I want to do is let's move these. I'm going to kind of move these out and over. And then we're going to rotate this, rotate that, and rotate that. So this, we can still move a little bit more. And then let's see, I want these to all be aesthetically, I want them in the same place, in the same column. So hit move this over, make sure that they're all far enough away from their sensor. Okay, and then I'm going to do right Align to middle. That looks pretty good. Okay, so I think that's going to help us out. I want to see if we can get these to be rotated. Because I think, again, I think that's just going to make life a lot easier for us if we can get these to take up less horizontal space. So those look like they're centered. Now we can do align to center. Okay. R12. So this is why earlier I didn't want to spend too much time on the silk screens, because here we just ran into where we're going to move some stuff around. What I don't like about this is now we're not going to get the silk screen on those, but now we're getting pretty darn close to that surface mount capacitor. Let's take a look at this in 3D. Yeah. Okay, we can move down a little bit more. See what that looks like. Okay. I'm okay with that. Okay, so I think those changes are going to help. What else did we say? So did that. Let's go double check that. PDM. Yep, those are done. We'll do the routing next, and then let's go and set up our net classes. So place, route, interactive router settings. Okay, remember to stay to shove. Maybe is that a universal setting? Maybe it's just because I installed the new version. Place footprints automatically. What? Well, never mind what I said earlier. Nah, I'm not entirely sure what that does. We should have played with that. What am I looking for? I'm looking for tools. Nope. Route. Why do I always miss this? Oh, track and via properties. Okay. Scope, tracks, vias, filter by net. Okay, filter item. Okay, this is like the silkscreen editor. Oh, this is why the net classes weren't working, because it's right here. We could have done it. I had it set to specific values, and now I have it set to net class. So if I do from here to here, we get a small one. And then from here to here, we get the bigger trace. Okay, so that's why. That is new. I didn't catch that's what's going on. So edit, track and via properties. So action is set to specific values, or wait, did that actually take effect? Let's try running this signal up around here. No. Okay, that's still not doing what I expect. Yeah, it is. Okay. Okay, cool. Yeah, I just totally missed that before. Can you move with the keyboard? Yes, you can. So that's what I was doing. So I just hit, you have to, and I keep messing this up. You select it, you press M for move, and then I'm just using the arrow keys to move things now. So escape to undo that. So yeah. Which is great for what we just did, right? Because made it nice and clean. Let's see. Then can human route what auto router can't route? Yeah, humans can almost always route what the auto router can't, because, well, we got to be careful. Auto router isn't like, it's not like there's just a library out there that's a function called auto route. So like, if they use any kind of iterative process, then they get smarter. But historically, the way the auto routers would work is you would tell it on each layer what direction to route signals, and then it would just try its best to route them based on that. They're certainly much smarter today than they were, but I'll just leave it at that. Better grab than move. The reason I'm not using G as much in PCB is because of the way it grabs the route. the tracks, I don't like. But that's more of a personal preference. Okay. So we do, okay, the other thing I want to do now is let's go double check with our friends at Osh Park. 4-layer board specs. I don't know what that word is. Let's try this one. So line width is actually 5 mil. Oh, wow. Okay. I do care about the stack up, but, well, actually this board I don't care as much about stack up because we're not doing RF this time. So tray spacing, 5 mil. Okay, we are going to reduce these then. So board edge keep out, 15 mil from nominal board edge. Okay. I don't know how far that is. That is 0.673 millimeters. That is 26 mil. Okay, that's cool. We are going to change our default. We are going to drop down a little bit. I'm not going to go all the way to their minimum, but nope, that's not what I want. Where is, gosh darn it. I feel like I should have, where did route tools, I'm looking for where you set the trace widths. Where was that at? And why do I feel like this moves every time I want to go to that menu? Not in our file. I mean, track and via properties. That's not what I'm looking for. And then why does that keep changing? Or was or is it that dialog doesn't matter and just we had a bug in the previous when we were doing the previous one? Is it under router settings? No. Inspect list nets? Nope. Tools? Nope. Preferences? No. Have I just lost my mind? Where's the dialog where we set the net classes at? I feel like I have what is boards? Okay, I don't remember going to board setup before to get to this dialog, but okay. So how big is a 0.8 millimeter? It's actually a good place for it. I'm not arguing that. I just yeah, that was odd. So via size, so let's go, minimum drill size is 10 mil. So let's make our via 12 mil and our via size be like 16 mil because 0.8, yeah, that's gonna be half the size. Shoot. I wanna do that on the signals, not on the power. So we'll make the via 16 mil and the drill 12 mil. Micro vias don't matter. Okay, power, it don't need it, but we're gonna set it anyway. Let's set this one to power. Assign to select it. That's on power now. Okay, let's save this much. Of course, you're going to complain about that. And the drop down of sizes. Oh, that's how we got to it. Okay, that's okay. Yep. Yeah, file board setup. That is, I mean, I'm okay with it being there. I don't know when it moved there, but that actually makes more sense to me that it's there now. I just couldn't. It was because I knew I had opened the dialog, but it was because we did the edit predefined sizes. Okay, and then the last thing is where do I change the layers? Because I don't think I want set layer pair. was it in board setup and I just missed it? But I want to tell it that we're going to have 2 more copper layers. And I don't remember where to do that at. 4 layers, parts on front and back. Signal. So inside copper 1 is going to be power. Inside copper 2 is going to be power. Can I do this? In 3-volt copper and then in ground copper. Let's do 3-volt. I've only done, in KiCad, I've only done 1 other 4-layer board, so this is a little bit new for me. God, that's bothering me that it keeps saying that. Okay. So now we've got front copper, ground, 3.3, and back copper. Beautiful. Okay. Okay. Click on layers. Yeah. Okay. We got it figured out. Hey, Thrylos 64. Welcome. Thank you for the follow. Okay. Well, we are ready to do the real layout now. Unfortunately, I'm out of time for the day. So we're going to pick this up on Wednesday's evening stream. So evening relative to Central Time, which I think is GMT -5. But I need to go and take care of some things, and I think it's going to take about an hour to then go through and lay out the traces. So I do want to do the routing live. So I won't do the final routing. I might try this again in the next couple of days just to see if there's any other major changes, but I do want to do the final routing live. It would normally, my guess would be it actually would normally take me about 30 minutes to finish this, but I want to talk while I'm doing it, and that always slows me down. So the other thing I might do in the meantime is I might clean up some of the silk screens, because that's gonna be pretty boring to watch, but we'll make sure we do the routing live, and my guess is we'll try to do that on Wednesday. And so I should have a schedule posted. I haven't updated it for this week, but it's going to be the same as last week's. So whatever times I had there. So I think Wednesdays I try to do like 6 p.m., 6 or 7 p.m. Central Time. Again, GMT -5. I think it was 7, because then that way it's 5 o'clock. Rodolfo, thanks for the positive comment on the videos. So yeah, so that is weird. When I change the source, KiCad freaks out, and I don't know why. That's weird. Okay, so I want to thank everybody for coming by. Happy Little PCBs. I like your name. That's a cool name, man. So I want to thank everybody for coming by. I'm happy with the progress we made. Basically, I'm confident now we can route this board, and I think it's going to come out. I think it's going to be a nice looking layout, so I'm pretty excited. We'll get to that. We have some silkscreen stuff to do. Like I said, I might do that like Monday or Tuesday off stream. There's no reason to watch. You guys don't need to watch me do that. I did want to mention, if you're looking for archive versions, I don't post live streams to the YouTube channel anymore. Pretty soon, I will start posting edited versions of live streams to YouTube, but I don't like doing just the full-on live stream. If you would like to follow, you can find me on Twitch. So if you're on YouTube, by the way, live streams are going to start moving over to Twitch. So Bald Engineer, or twitch.tv/baldengineer. We also have a Discord server. So if you'd like to keep the conversation going or know what's going on, feel free to join that. Very often after a stream, I'll it won't be today because I've got to go do other stuff. But like if I do updates to the board between now and Wednesday, I'll post updates in the Discord. And if you have questions or things you want to talk about related to electronics, feel free to stop by. We've got a lot of really cool people that like to help out. So again, I want to thank everybody for coming. I also want to take a moment and I thank the people that are supporting me on Patreon, because Patreon does actually help quite a bit to fund some of the projects that we do here. So for example, when I get these boards made, they'll actually get paid for out of the Patreon fund. So that's why I wanted to mention those people that are help supporting. Excuse me. For those of you in the US, I hope you have a good Memorial Day. I probably won't be doing much in terms of this project, but I will hopefully, assuming that the putting the barbecue grill together project goes well, I hope to enjoy some barbecue tomorrow. So once again, thank you to everybody. Have a good evening or morning or afternoon. And then for those of you on Twitch, let's see if there is anyone doing science or technology. Let's see. That's not a good. I've added a couple of new people and they didn't show up on my list just now. So I want to see if any of them are. Oh my gosh! Why are you making noise? Be quiet. I will send you over to. Let's go to T Sodding. He's been kind enough to send people our way a few times. He does programming. In fact, he was doing game programming last time I watched his stream. So not quite electronics, but still kind of cool science and technology. So let's send you guys over there. Please tell him I said hi. I'm not going to join the raid because I need to go take care of other things. But let him know that we were doing some stuff in KiCad and drawing circuits and stuff. And stick around and watch him. I also think he's entertaining as a streamer. So everybody, have a good day. Thank you. And that's still not working. Why didn't that one work?